This is the solution video of question number 2 of the modules on Mohr's circle of 2D stress and strain transformation. In this question, we're going to draw a Mohr circle that describes each of the following states of stress. So the first thing we want to do, we want to define all the formulas that we need and the kind of beginner step of Mohr circle. You might recall from your lecture that it's referred to CR squared. We have C and 2 R's that we need to find. So step 1, we want to find our center point. And our center point C is the same as our average normal stress. So our normal stress in X plus normal stress in Y divided by 2. Step 2, which is the first R in here, refers to our reference point. That's often annotated A, which basically we just note down the coordinates, so the normal stress in X and our shear stress. And then our last step before we draw Mohr circle, step 3, is the last R, which refers to the radius. Our radius, it's simply calculated from the square root out of our normal stress in X minus our average stress squared plus our shear stress. So let's start by writing out what we have been given. So for our A, we have been given a normal stress in the X direction, 600 kilopascals, and a normal stress in the Y direction as 700 kilopascals. In here, we have no shear stress, 0. We can now apply these steps of beginning Mohr circle, so finding the center point, finding our reference point, and also our radius. So step 1, we're going to find the center point, and I'm just going to use the formula directly as we wrote them here above, plus 700 divided by 2. And we find that our center point is located at 650 kilopascals. Then we have our step 2. Again, it's just to copy down our reference point. Maybe we'll do a little line in between here. So A located at 600 and 0. When we have enough room and we do our step 3. Our radius, (600) minus 650 squared. And again, we don't actually have shear stress in this one, but I'll still put it in there. And what we find, our radius of this circle is 50 kilopascals. So now we have all the values for us to be able to start drawing our Mohr's circle. Since I'm doing this on my computer, I'm just going to simply start with a circle because I know my radius, right? 50. It's not very big. Also have my normal stress axis, which is the horizontal axis. Again, it's positive towards the right. And then we also have our vertical axis, which is our shear axis. Perhaps that goes a little bit further to the left because our center point, which I'm now going to mark out over here, is located at 650, which means when we only have the 50 kilopascals, we know that the whole circle is going to be located on the positive side of our coordinate field. Let me just mark out that we have our positive shear downward. From this, we can also put where we have our reference point A, which is at 600. So what we'll find is that this is our reference point A, which is located at 600 and 0. But this is also our principal stress too, which is the same as our minimum principal stress. Then we have our maximum principal stress, or principal stress 1, located on the right-hand side. And for our maximum in-plane shear, located on the positive axis, down here. What we'll find is that our maximum in-plane shear stress is the same as our radius. Our principal stresses is simply just our center point plus the radius for our maximum, and for our minimum is simply just the center point minus the radius. But we don't have to calculate these ones, we simply just have to display where they are. Let's go up and look at our B. In part B, we only have a normal stress in the y direction, which is 4 megapascals. So we're going to go ahead and start displaying part B. So normal stress in y equals to 4 megapascals. Oh. In X, 0 and no shear stress. Since we know this, we're going to again, step 1, find our center point. Simply just the average, which would mean in this case, it will be 0 plus 4 divided by 2 megapascals. Step 2, our reference point A, just located at 0, and then again 0, because we don't have a normal stress in X and no shear stress. Then we have our step 3, which is finding our radius. And again, our normal stress is in X direction is 0, and our average stress is 2. So our square root out of 0 minus 2 squared plus our shear stress, which again, 0 squared, which will simply just give us 2 megapascals again. we'll just draw our coordinate field first, our shear axis, our normal axis, and the neat part with having our center at 2 and a radius of 2 is that the edge of our circle is going to be intersected with the origin. So let me draw my circle. I'll just align that with the origin like that. I note out my center point. Obviously, when you draw this by hand, it's obviously need to find the center point first, like I did in section A. So this is my center point. My reference point, again, located at the intersection between the shear and normal axis. So my A located here, but so is my minimum principal stress or principal stress. Maximum principal stress or principal stress 1 located on this section here. All right, so my maximum in-plane shear stress is again located at the bottom of the circle, max in plane. Let's go ahead and do section C. So we don't have any normal stresses. We only have shear stress at 40 megapascals. So let's see what we've been given. So for C, there's no stress in the normal X. There's no stress in the normal Y. But we do have our shear stress, which is negative 40 megapascals. Again, we start with step 1, which is finding the center of the circle, which is just our average. So again, 0 plus 0 divided by 2 is still going to be 0. Not much to find there. Step 2, our reference point. And again, reference point A at 0 and at our shear stress, negative 40. Step 3, we are finding the radius, right? So radius is the square root. It's very long, square root, but let's see how much we need. Step 3 is finding our radius. And again, because we don't actually have that much, most of our parts are going to be 0. So 0 minus 0 squared and plus minus 40 squared. Simply just going to be 40. We'll go ahead and draw out our Mohr circle. So the neat thing about this question is that our center point is going to be at 0, so it's going to be located at the origin. So we'll go ahead and draw our horizontal line, which is our normal stress, and then our shear stress. Again, I know my center point is now in the center, or in the origin. We'll add our circle of our radius 40. What we'll find, again, our minimum shear stress is located on the left-hand side, maximum on the right-hand side, and our reference point A at negative 40, so upwards direction on the shear axis. And again, our maximum in-plane shear stress is located on the bottom of the circle when we decide that this direction is positive. And the neat thing when our center is located in the middle is that our minimum normal stress simply just going to be the negative radius, and our maximum is going to be the positive radius. So it's positive 40 and negative 40. Funnily enough, our maximum shear stress is going to be a positive 40, and that concludes this question.